All right, hello, welcome to chapter 1.2 exercises. We're going to do a smattering of these problems. The exercises for this assignment are page 17, 15 through 17, 21 through 25, 29, 33, 37, and 39, all odd, of course. I'm going to be doing 6 of these problems, so quite a few, but you can see some of them don't take a whole lot of time. So let's start with number 15, jump right into it. Let me write that in there. Number 15. Okay, so 15, it gives us this drawing where it says find m and n. Let me go ahead and I forgot to sketch this ahead of time, but let me do it real quick. We've got m, and then we have n, and we have r. And the distance between n and r is variable x, and over here is 2.5x, and the entire distance has been given to us as 5x minus 3. Oh boy, so we're going to get to do our algebra right off the bat. But 15 is a great example of, I think there's several problems on the exercises where you're just solving using segment addition postulate and to write equations and solve for x. So you're getting to refresh your algebra skills. Notice there's no mention of n being the midpoint, so it's not like 2.5x equals x. If it did say that, midpoint, that's always look for those two equal halves. But in this case, it's just the straightforward addition postulate. We know that this piece plus this piece equals the big piece right down here. Okay, because remember what I said if you watch the homework, when solving for when trying to solve for x, you always want to write an equation. What is equal to what? Well, in this case, we'd have to say 2.5x plus x. So these are the two segments, mn and nr. They're equal to the entire length, which is 5x minus 3. Okay, if I wrote this in just to kind of show, again, start off kind of slow, the class is just getting rolling, I'm basically saying that mn plus nr is equal to mr. That's the segment addition postulate in action. Okay, and again, it's kind of common sense, but just moving slowly to guide you through that. So here we go. We've got 2.5 x's plus another x. That's a 1x, so that means we now have 3.5 x's. That's exciting. 3.5 x's equals, 5x minus 3. Okay, so now I want to get my x's on one side. So that means my next step would be to combine these x's. I'd want to subtract them. Since I don't like negatives, I'm going to kind of do this. Well, maybe we'll do it. We'll try it this way. Go ahead and, since the 3 is already over here, let's subtract the 5. So I'm going to subtract 5x from 3.5x. Okay, I'm subtracting because this is a positive 5. You're always doing the opposite so that they cancel out. So the 5x's are canceled. Basically becomes 0. And now I have 3.5x's minus 5x's. So 5 minus 3.5, or think about it as like $5 minus $3.50. That's going to leave me with 1.5. So now I have 1.5x equals, now don't lose your negative because that's a minus 3. So and this is a negative 2. Sorry, negative 1.5x equals negative 3 over here. Because it was a minus 3. So pay attention to your negatives. And so now I have something times x equals it. So what's the opposite of multiplying? That's correct. It is dividing. So I'm now going to divide by 1.5x. And again, I know that's the right step because I can see if I do negative 1.5 divided by 1.5, that gives me 1x. So it's basically canceled. But then in algebra, I just make sure I do the same step on the right. Okay, so this cancels out. And so now we have negative 3 divided by 1.5. Alrighty, and so that's going to be 2. Okay, 1.5 fits into 3 2 times. And because I've got 2 negatives, my answer is now positive. So there we go. I now have found my, I now have found my x. Going back to the problem, am I trying to find x? I'm trying to find mn. So I'm trying to find this distance. So I'm not done yet. I've got to plug this in right here because it says to find mn. Okay, so let's plug it back. There it is. So we just need to do 2.5 times 2. So 2.5 times 2, that is simply 5. Check the book. Always check your answers in the back of the book. That is correct. There's no unit, so I don't need to say 5 inches or 5 centimeters, but that's good to know. But notice we have a lot of work on this problem, so there's my beautiful box to show I finished the problem, Mr. Mefford. There it is. I've also worked vertically, and so we can follow my thinking. If I made a mistake anywhere, I can go back and I can say, okay, where did I go wrong? Or if I'm helping you or a parent or a friend's helping you, showing your work is really valuable. Okay, so there's a typical example of where you're going to be writing equations using the segment addition postulate to solve for x. Sometimes x will be your answer. Sometimes you'll need to plug it in, more likely that, plug it in to find one of the lengths of the segments. In this case, we found mn. Obviously, we know what nr is. nr is 2. And if they asked us to find mr, well, we could just add those together. We can see that, again, we can see, I'm just kind of extending the problem. I know this is 5. I know that I found x is 2, so I could also know that m all the way to r, the entire length, is 7. And so once you know x, you can find all the other distances in the problem. Okay, let's do another one. Let's go ahead and we're doing number 23. I'm going to do number 23 with you. 23 is just another algebra problem, just slightly different. So 23, and again, got a drawing that I need to make for it. Sorry, I didn't do these ahead of time. So we've got D in the middle, C, H, F, G, got a little guy, R, E right here. Okay, and so it says that GH bisects CF. So GH is bisecting CF. So if you remember what bisecting means, it means it cuts it in half. So that means CD is equal to DF. Okay, that means it's been cut into 2 equal halves. So that's useful information because now I know that I have 2 equal halves there. And so then it gives me those distances. It says that CF is equal to 2y minus 2 and CD is equal to 3y minus 11. Find CD. So in other words, they've told me that the entire length, CF, is 2y minus 2. And they've told me that CD, half of it, is equal to 3y minus 11. Here, let me zoom back in. Okay, so the key is, as always, what equals what? Well, in this case, I can see that 3y minus 11 is half of the entire line. So in other words, if I were to multiply that by 2 times this half CD, 3y minus 11, if I did both halves this and then another half, that would be equal to the entire length of CF, 2y minus 2. Okay, so there's my equation. If I double the half that I have, 3 minus 11, I'll be equal to the whole. So let's go ahead and work our way through that. Okay, so 2, I'm going to distribute this to outside parentheses. So it's going to be 2 times 3y, that's 6y, and 2 times negative 11, that's going to be negative 22, equals 2y plus minus 2. Okay, let's go into algebra mode. Okay, I want to get my y's together. I want to keep my y's positive, so I'm going to subtract this 2 from here, because again, that's going to cancel it out. But let me do it, I have to do it both on both sides. So we subtract the 2y. So 4y minus 22 equals negative 2. All right, now let's do the same thing with that constant. I need to get rid of this negative 22. What's the opposite of negative 22? Positive, or adding 22. So there we go. And again, that's key because that cancels that out. And so we get 4y equals, let's see, negative 2 plus 22. That's just 20. Alrighty, now we've got 4 times y. What's the opposite of multiplying by 4? We're going to divide by 4. So that, again, that cancels out. 4 divided by 4 is 1, so that just leaves y by itself. Oops. So 20 divided by 4, so we get y is equal to 5. Y is equal to 5. Okay. Are we trying to solve for y? No, we're trying to find CD. Trying to find CD. Oops. So let's zoom out a little bit. So CD is just the half, so that means I need to take my y and plug it in right here because that's CD. So we're going to get 3 times 5 minus 11. Okay, so that's 15 minus 11. That just leaves me with 4 equaling CD. Now if I check the back of the book, I can see that that is correct. So box my answer. Notice that we're kind of doing the same pattern again and again, but I want to work through 2 of these. One, to kind of do the algebra review with you, but also just to show you the setup. Again, they gave us, the key to this one was writing the correct equation, which was knowing that CD is half of the entire thing. So as long as I double CD, it's equal to the 2y minus 2, which is the entire length of the segment. Then we solved for y, and then we plugged y back in order to find what they specifically asked us to look for, which is CD. Okay, 2 little bit longer problems, but again, we're starting off early and being distance learning. I want to work through it slowly with you. And of course, if you don't need this help, rock and roll. You're on your own. You can do it. Okay, 25. Let's take a look at 25. 25 is an example of a type of problem you'll see throughout the year, and that's these always, sometimes, never true. They'll give you a statement, and if you have to find out, is it always true? Is it sometimes true? Or is it never true? And so the key is to read it and think, okay, can I give a counter example? If I can't find a counter example, it's probably always true. If I can't find an example of it ever being true, then it's probably never true. And if I can find one of each, then it's probably sometimes true. So let's look at 25. It says, if M is between A and B, then M bisects A and B. Okay, so if M, here's point M, is between A and B, then M bisects A and B. Okay, well, if you remember, bisect means that to divide into equal halves. So I could imagine it being true. M could be right here in the middle, and if those were equal, M is a bisector. It's a midpoint of A and B. So that's true. So it's not never. I know that it could be true. However, does it always have to be true? Is M, if it's between A and B, always have to be a bisector? Well, no. I can also imagine, no, I could do this. Here's my A and my B. But what if M were right here? Okay. In that case, you can try to make it very evident. You can see that M is not directly between it or A and B or cutting it in equal halves. So it's not always true. And so this would be an example. Since I can find an example of both of these being the case, our answer would be sometimes. Okay, that is sometimes true. So again, it said to support my answer with a sketch, so I did that. Okay, so the key is to play out both scenarios and see if you can get one for both or one for the other. And that way you'll know if something's always, sometimes, or never true. Okay, number 29. Let's take a look at that one. This one had to do with coordinates, so I wanted to work through that with you. Okay, 29 says, a coordinate of M is 2.5 and MN is 4. What are the possible coordinates of N? So now it's actually talking about being on a graph. So we draw out our graph. It's saying that you've got a coordinate here, and it is, I should probably try to put it in the middle. You've got something that's like 2.5, 2.5, and that's coordinate m. And then it's saying you have this line called mn, and the distance of that is 4. Okay, so what's the coordinate of n? Well, okay, if I'm at 2.5 and I have to travel a distance of 4, then it just must simply be 2.5 plus 4. That would be 6.5. So that would imply that n's coordinate is 6.5 because it's 4 away from the 2.5. So that's pretty straightforward once you can visualize it. Notice it says, though, what are possible coordinates? In other words, there's more than one possible answer. So that's would imply you'd look at the picture. Well, how could how could you have a distance of 4 but have it be a different value? Well, that's because we could go in this direction. What if n was right here? Okay, what would that value be? Well, that would just be 4 less than the 2.5. So in other words, 2.5 minus 4, because it could be going in either direction, even though mn doesn't always imply you're going left to right, even though the alphabet goes that way. So mn could go negative to the other side. So 2.5 minus 4, that's going to be negative 1.5. So if I went negative 1.5, I'm sorry, if I went 4 this way, and you could draw the number line and actually count it out, this would take you past 0. 0 would be right about here, and you'd actually be at negative 1.5. And both of these numbers are 4 away from 2.5. So that's why there's more than one possible answer. So we'd want to say our possible coordinates are 2.5. I'm sorry, whoops, not 2.5. Are 6.5 or negative 1.5. Box it. Okay. So drawing that one, solving that one by looking at a number line. Okay. Two more, 37 and 39, the multiple choice. I will usually try to give you a multiple choice, 1 or 2 at the end of each lesson. The majority of our tests will be multiple choice. And so kind of getting you used to that. Okay, 37. We've got this line here, a segment, I mean, and we've got point A, B, C, and D. And it is saying that C is the midpoint of AD. Okay, so I'm going to start writing some of this out. So C is right in the middle of A and D. So those two things are equal. And then it says B is the midpoint of AC. So I've got another midpoint right here. So in other words, AB is equal to BC. Okay, and then it gives me a value. It says BC is 12. So now I need to find the length of AD. So that AD, that means I'm looking for this entire distance. Okay, well, knowing midpoints then allows you to know a lot of information. If BC, notice as I read it, the other key thing to making these easier, if you find them a little difficult, is like I just did, drawing them, adding to the picture. That's why sketching it in your workbook, your comp book, and then doing exactly what I'm doing here. Again, if I just read that and I think about it, I might be a little confused. But if I write it down, the answer kind of jumps off the page because I can see, well, if BC is equal to AB, well, I know what AB is. AB is 12. Okay. And I know that if I know those distances, I now know A to C. A to C must be 12 plus 12. So this right here must be 24. All right. And I already figured out that C is the middle of AD. So that means this distance over here must be 24 as well. And that then implies, so the entire distance must be 48. So no equation writings or anything like that, just kind of can infer the answer because I've correctly written down the information. And it's, again, a lot of times the information on these problems is cumulative. If you just try to take it all in all at once, it's hard. But if you write down and sketch each fact one at a time, then you can kind of back up and see what the conclusion will be. Okay, so I won't rework that. You can rewatch the video, but we now can see that AD is equal to 48. And I can look, do I have that as an option? Yeah, in the multiple choice, that is option J. So I'm going to go with that. If you check the back, that is correct. Alrighty, one more multiple choice. Decided to work through quite a few with you this time. 6 problems. Normally won't be quite so many, but I love you. Want you to succeed. Want you to get off to a good start. 39. Nice to be with you today if you're working through this video. All right, so now we've got another drawing. Let's see, they draw them crooked, so I'm drawing them crooked, but maybe I'll draw it flat. And we've got A, B, C, D, and lonely little E over here. And it says they are collinear points. Okay, we know what collinear means. All in the same line. That's correct. Okay, now I'm going to start. They're giving us information. Here it comes. AE is 34. Okay, so they've given me the entire length as being 34. All right, and then they say that BD is 16. B to D is 16. Okay, and then it says that AB is congruent to BC, so that means these are the same here. And it's saying also CD. So I'm going to put these hashes because I know that those distances are all exactly the same. Okay, now I need to find the length of CE. So they want to know, so from C to E. So kind of a weird piece. It's not like I might have to reason my way to this. I can't subtract it. It's not like you might want to be tempted. Okay, do I take 16 and 34? Do I add them? Do I subtract them? Do I multiply them? Well, we got to slow down and let's reason our way a little more slowly than that. So we can see that. So if I know that B to D is 16 and AB, BC, and CD are all congruent, I can figure out those distances. That means that C is a midpoint. C is a midpoint of B and D. So that means this must be 8. And this must be 8, right? Because it's dividing those in half. And if I know that what BC and CD are, I also know that AB must also be 8. Okay, so now we're getting somewhere. Okay, because now I've basically found A to D. So that means I know I can figure out what DE is, this distance right here. Because I can see that 8 plus 8 plus 8, or 3 times 8, that's 24. So that means this piece right here, A to D, is 24. And if the whole thing is 34, the difference there is DE. So I know that DE must be 34 minus 24, 10. Okay, so now I know the length of every segment. AB is 8, BC is 8, CD is 8, and DE is 10. If I add those all up, it is 34, so I'm within the facts they've given me. So now what am I trying to find again? I'm trying to find C to E. Well, that's 8 plus 10. So that means CE must be, oh, I'm sorry, 8 and 10, so CE must be 18. Do I have that as an option? Yes, it is H. Bingo. Boxer, and we are done. Okay, so there's a sampling of some of the exercises. Wanted to work through quite a few because they're all a little different, and wanted to kind of, again, help you through these first couple lessons as much as possible, especially since we can't be in the classroom together. But as you have any trouble with any of these problems, please reach out to me. We'll be having classes again Monday, Thursday, and Friday, but I'm happy to help you and jump on a whiteboard and walk through any of the exercises with you at any time. Even if it's just one little question, that's fine. We can talk for 2 minutes and we'll be done. So please, if you need help on the homework and you can't reach out to a parent or a friend to help you through it, don't sit there and be confused. Please reach out and get the help you need, because that's why I'm here. All right, good luck.